All right, let's do some SPSS two-way between subjects ANOVA. Let's see how I do. This is a famous study from the 1970s. They were really interested in how our perceptions of others, social faux pas affected sort of what we thought about them. In this case, it's in terms of likability. There's a whole series of studies on this. So when I first read it, just because I'm not that old. I thought they used videotapes of people, and they were observing them, and they would either make a mistake or not make a mistake. But no, they had a Confederate who would walk in the room in real life and uh, say the same things to the participant. But sometimes they had a pre-planned sort of mess up they do or not. This particular study not only looked at how people's social faux pas affected how we thought of them, but it also included a variable that's inside the observer. So how about how you feel about yourself, your self-esteem? This study has two variables. One, so everyone's meeting an observer and talking to them, and they have to rate that person's likability, how likable they are. Um, Half the people saw the person make a goof or a blunder. They spilled coffee on themselves or something. Half they didn't happen. And then the other variable was they had them take the observer, the participant in the study, take a self-esteem test. And based on that, they grouped them into low, medium, and high self-esteem of the study participant. So that can get a little confusing. So I got the data file open. Let's get this one rolling and see what these guys found. So what is the one dependent variable in the study? Well, that seems like an easy answer. It's likability. So I'm going to throw likability in here. Hope I am not doing trick questions. What are the two independent variables in the study? So A and B, well, Scott even labeled them for you here. So A is participant self-esteem, and B is social blunder condition, which there's two levels. One was observing an individual spill coffee on themselves. That's the blunder condition, or no blunder, which they did not. They still observed the person, but they didn't see him spill coffee. Let me blow this up a little bit, make it a little easier. There we go. So next question, how many ANOVA effects are estimated in this analysis? So if you paid attention during the lecture, did the reading, you would know that in a this is going to be a two-way analysis of variance between subjects analysis of variance, which means there is a main effect of each of the independent variables. So a main effect of self-esteem, a main effect of social blunder condition, and then a third effect, which is their interaction. So how many ANOVA effects are estimated in this analysis? Three, two main effects and one interaction. What is the name of the effect of the independent variable A, participant self-esteem, combined across all levels of independent variable 2 social blunder? That is I'm going to cheat a little bit here, main effect of participant self-esteem. So it is the main effect of participant self-esteem. How about the other one? What is the name of the effect of independent variable B, social blunder, combined across levels of independent variable A? You guessed it, it is the main effect of social blunder condition. So main effect of, and where am I copying this from? Probably up here, social blunder condition. All right, doing good so far. It's almost like I teach this or something. What is the name of the combined effect of independent variable A, participant self-esteem, by independent variable B, social blender condition? I mean, how crazy you want to get on this, but technically it's the two-way interaction of social blunder. I'm just going to copy them both at once. And by so it's the two-way. Let me make these bigger because I'm not sure you guys can see them the way they currently are this small. Make it bigger, font, 12. No, it's because I'm pasting, huh? All right, so we got the main effect of participant self-esteem, main effect of social blending condition, two-way interaction of participant self-esteem. I guess I could say and, but I put an X by social blending condition. All right, so that is trying to garden path you. So you know you should be looking for three effects in the analysis. So let's go ahead and run this. So there's two levels of each. So this is no, there's 2 and 3 levels. So it's a 2 by 3. Please tell me good, I did it right. All right, so let's go over, follow my instructions to analyze. And we go to general linear model and we go to univariate. Under univariate, we've got to throw some variables in box. We got to take our likability rating and put that in the dependent variable box. Then we got to move both of the independent variables over to the fixed factors box. And we got to get e-means. Hopefully you did this because otherwise you couldn't get your simple effects tests by clicking syntax. So get display means for all three, the main effects of each and also the interaction. That's kind of it. So the plots button, gonna get a plot. So move participant self-esteem into the horizontal axis box. So social blender's got to be going to separate lines floor or separate lines box. And click add. So this time I just want you to keep it as a line chart because this is for a two-way interaction. Continue. So because participant self-esteem, we talked about this in the lecture, is an independent variable that has more than 2 levels. The main effect, if it's significant, all you know is, okay, there's some difference among the 3 self-esteem groups and their overall likability ratings of the persons they observed, but you don't know who differs from who. You have to get follow-up simple effects tests. So let's do that. So click the post hoc button, meaning after the fact in Latin. We got to move participant self-esteem from the post hoc test to the post hoc test for box. So self-esteem is going over here. And under equal variance is assumed. So right here, select Tukey. So let's get our Tukey. I just tell you don't get Tukey's B, get Tukey. Click continue. And this is long. Then go to options. Got to get descriptives right there. Homogeneity test for our Levine test. And I do give you a hint here that if you get estimates of effect size, I'm going to get it. Homogeneity test, because incorrect. So I'm actually telling you do not get it because it messes you up. All right, so I'm just going to, I told you got to hand calculate those anyway. So I got descriptives, homogeneity tests, click continue. And if we've done it correctly, it should look like this. And click paste, which we've never actually done before. So it turns out SPSS is a programming language. This whole time you're selecting things, it is writing code in the background, which used to be amazing. But now, chat, the various LLMs just write code for us anyway. So here we go. Things just get better. So in this box, this is the code. Like you can highlight this and run it, and it would run what we normally run. That's actually a run button. I don't know if you guys grew up with CDs or anything that had a run button, but that's what this triangle is. Or you can go to run all. So what we have to do is a little bit of editing. So these lines right here we got because we put the main effect and interaction, do that into the e-means box. On that line, you got to put this compare social blender condition at the end. And what that's going to do is it's going to compare the 2 social blender conditions and do it within each level of the other variable for participant self-esteem. So I'm just gonna copy this on over, paste it in there. And there we go. Do you need a space or not? I can't tell if there is one, so let's put one just in case. The answer is yeah, you think you need a space. So it should look like this. E means participant compare social blender condition. Maybe I didn't need another space, but whatever. So I'm going to run this, and again, highlight it and click that. Or you can, do I say to highlight it both times? Anyway, I always highlight it just because I've had some bad things happen. It runs like stuff you don't want it to. I'm going to go to run all, and it's actually running that code. And here is the results of our analysis. So it has been printing the code at the top of things if you guys turn on that option. So it has been there. I'm going to be a good student and make sure to put my name on here. Master, just so I don't accidentally forget later and make the TA mad. All right, so here we go. Using the check the homogeneity variance assumptions required by ANOVA, using the based on mean row, blah, blah, blah. Let me scroll down. Here's our homogeneity variance test. That's the based on mean row. Uh, the question is, using alpha of 0.05, does the data appear to meet the homogeneity variance assumption? Or said another way, is sig greater than 0.05? Yes, sig is greater than 0.05. So I kind of like that second way because you just go, yeah, sig is greater than 0.05. It meets the homogeneity variance assumption. We got about the same spread of scores in all cells of our 2x6, our 6 cells of our 2x3 design. So we got to get, this is just here to give you the formula because we're going to end up needing it. We got to fill out our ANOVA summary table. That comes in this test of between subjects effects. I've tried like pasting in here to make life easier and just have not succeeded. So I'm going to end up typing them. But I did learn a trick here. There's so much extra crap they print now. If you double click on things in SPSS, you can edit them. And I'm going to highlight the rows I know we need. So I need participant self-esteem. I'm going to highlight that row. And it's actually this right here. I'll make it yellow. And social blender is another row I know I'm going to be copying from. So I will highlight that row as well. I think I did it. Who knows? I mean, this is not the world's best functionality, but there we go. What in God's name did I do? And then highlight this row and same thing, go to yellow. Yeah, that row, I don't know if I messed it up or what, or if it's just, whoa, it's wigging out. Okay, time to close that. Yeah, I didn't do the highlighting. Let's try that again. Yeah, SPSS used to be its own company, then IBM bought it, and it's progressively just gotten cheesier and sort of more troubling. So, and we need the error row. So I'm doing this because I'm old and it helps me track. Those are the rows I know I need, and then when I'm doing the computational problem on this, I'll know these are the rows I need. So, hey, why not try it? So we need sum of squares, degrees of freedom, mean square, and F. Yeah, I'm going to try copying this because I am trying to get this done quickly. Copy that. Please work. Please work. And paste. Of course, it didn't work. Of course. Try one more time. I think I can't go down to the total row because can't copy those. All right. Anyway, that doesn't work, you guys. Time to type. So 20.58, 2 degrees of freedom, 10.29. And 3.800 gets a star, or sorry, 3.80. And it gets a star. Why? Because sig is less than 0.05. Right there, not much, but all right. Next row is, so what did I do here? Whatever. Next row is 9.38. And that's got 1 degree of freedom. And so it's also 9.38. And our F value way over here is 3.46. And I'm going to get, does it get a star? No star for you. Bummer. So no star on that one. Social blunder. So then finally, we got our interaction here at 113.25. That one's got 2 degrees of freedom and 56.63. And our F value is 29.91. Definitely gets a star. We got an interaction. That's exciting. Our within error is 48.75. 18 degrees of freedom and 2.71 is our MS, or mean square. So I got to get the total here. So let's get the total here. I'm just going to use calculator on my computer because I'm sitting at my computer. So 20.58 plus 9.38 plus 113.25 plus 48.75 is 191.96. 0.96. We're going to need that number. I know 18, 20, 21, 22, 23. That seems like so far we're doing pretty good. Okay, so let's move on to doing our eta squareds. Luckily, the formula here is kind of all the same. So you got to get the bottom of this sum of squares total, but we got it right here. So it's just going to be dividing each one of these things one at a time by that bottom. That's going to get us our eta squareds. So I'll use my calculator. Apparently, I got a lot of this calculator going today. There we go. So 20.58 divided by 91.96 is 0.107. That's going to round to 0.11. So far, so good. Next one is 9.38. This first one right here. Divided again by 191.96 is 0.05, rounded. And then final one is 113.25. That's also divided by 191.96 is 0.5899. So that's going to be 0.59 overall. That is a big effect, 59% of the variance. All right, let's see what computer says. So using alpha 0.05, is there a significant main effect of participant self-esteem? So participant self-esteem, yeah, it's significant. So there is, I mean, the answer is yeah, yes, simple. What are the three means being compared by the main effect of participant self-esteem? So you can get those different places. This one's sort of right in your face. And it's a good time to get it because I didn't ask you to get standard deviations. The other place to get it is the descriptors table up here, but it's less obvious. So what you need is low total 9.25. So medium total 11, high total 11.38. So those are the three means, but I'll just show you it's the same down here. Boom, boom, boom. We don't have any covariates, so the quote unquote adjusted means turn out to be the same as the actual means. So 9.25, 11.00, and 11.38. Those are our three means. So we know that at least one of these differs from at least one of the others because the main effect's significant. Using alpha of 0.05 and the results of Tukey, reporting the results for each individual contrast. Okay. So I haven't done a Tukey in a while, I'm guessing. So let's go find this table. This has got to be it. Multiple comparisons with participant self-esteem. So if you remember back to one-way ANOVA, probably don't, but what this does is it compares each level of the independent variable to each other level, and it adjusts for your type 1 error inflation. So as part of calculating the sig values. But basically, we just got to find the three we need, which low versus medium, low, high, medium, high, low versus medium. There it is right there. And so what are we supposed to write in here? It's my own instructions. Describe the results of each one. Oh, okay. So low versus medium, the very first box is 0.112. There is no significant difference between low and medium. So lots of ways to say this, but I would say not sig, something like low, for all intents and purposes, equal to medium, meaning no, not significantly different. So how about low versus high? Low versus high is less than 0.05. So this is sig. All right. But the question is, all right, who rated this person as more likable? Those with low self-esteem and those with high self-esteem. Well, here's our means. Low is 9.25, high is 11.38. Well, people with high self-esteem rated them as more likable. So lots, again, ways to do this. I'm going to say low was less than high. Just put it in shorthand. So medium versus high, we got to go to medium versus high, not significant. So similar conclusion, not sig, and medium is equal to high. And it's our two key tests. Interpret the results, main effects, what are the main effect. So what's it tell us about whether and if so, how the independent variable affected / was associated with differences in the dependent variable. So only one of the three possible differences was significant. So my approach to these things is to start there with the significant stuff, and then sometimes you get thrown a line that just says, and none of the other differences were significant, which is probably what I'm doing because it's getting late. So what do we know? Well, we know that low rated the persons they observed as less likable than those with high self-esteem. So I'm going to say persons with low self-esteem rated the person they person or people, I guess that'd be the right word. People they observed as less likable than people with high self-esteem. All right, I can actually put that in my write-up. Not bad. So what about the other differences? We got to say something. So I think you could say, however, low didn't differ from medium, and medium didn't differ from high. I was going to say no other differences were significant. Boom. All right, using alpha 0.05, how about social blender? Main effect? There wasn't, right? Let's see here. No star, and I'll verify it up here in the table. Social blender was 3.46. Where are you at? There we go, 0.079. So no, not significant. So was there a main effect? No, there was not a main effect of social blender. So just no works. Still asking for the means. I'm going to get them from the easy spot. They're down here, social blender. 9.92 for those who saw the blender versus 11.17 for those who did not see the blender. 11.17. That's pretty interesting, but not significantly interesting. All right, so why is there a Tukey test in the multiple comparisons SPSS output? I swear to you, there's not. Here's our Tukey. There is no test for it down here. So why is there no test for social blender? Why did we have to do it for self-esteem? We had to because self-esteem had 3 levels, and we had to figure out exactly which levels differ from each other. Whereas social blender only has 2. So even if there was a main effect, it was significant. You just got to look at the means. You don't have to do any fancy follow-up tests because there's only 2 things that differ. So you just figure out the direction from which mean is higher or lower. So why only 2 levels of social blender? We didn't be like total hide your face embarrassing as a 3rd level. So interpret the results, the main effect of social blender, blah, 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 blah. So when something's not significant, you conclude, well, there's no effect, nothing, didn't do anything, something along those lines. So I'm going to say overall, as obviously there's going to be differences for subgroups in here, but overall, the blender and non-blender people did not significantly differ in their likability ratings. All right, something like that. So using alpha 0.05, is there a significant 2-way interaction? You bet there is. We saw it earlier, but just to prove it, there's our sig value for our interaction, participant self-esteem by social blender. So the answer here is yes. So grab all the means and grab the standard deviations. This is where you definitely don't want to use this table down here. So it does give you means, but it gives you standard errors just like last week. So we definitely want to go to descriptives where it just gives us normal stuff. So let's see, low self-esteem, social blunder. It's in the order, so 6.25 was their mean. Oops, 0.25 for standard deviation of 1.71. And then let's see, low did not see the social blunder. Mean was 12.25. That sure seems different. And standard deviation again of 1.71. Medium self-esteem, same thing, 13.25 and 1.71. And then 8.75 and 1.71. All the standard deviations are the same. That seems sketchy, but I think I know why. And it's okay. So high versus who saw the social blunder? 10.25, 0.25, and high, that's, oh, I did the standard deviation. 1.71. And then the final two numbers we got to put in this ginormous table is high versus high with no blunder. Their rating was 12.5. And they had a standard deviation of 1.29. All right, why did we do that? Because there's a means table in the write-up, and so I wanted to make it so you can copy and paste into it. So what excuse me, what is the appropriate Bonferroni corrected alpha level to use for simple effects ANOVAs? I don't know. So you need to know how many tests you're running. So, excuse me. I think the easy way to do this is go look at that output section and see how many, tests are in there, how many ANOVAs. So that's probably what I'm going to go do. So let me find that section. It is in a section that is called, hopefully I tell you guys, univariate tests again. All right, let's go find it. Pairwise, there is our univariate tests. So notice in univariate tests, I wish they spent more time in SPSS, like learning how to label stuff well, but this is a test for low. It compares among low people, those who saw the blender or not. Same thing for medium. Same thing for high. So it's comparing the blender condition within each of the self-esteem conditions. And this note's supposed to help you figure that out. This is totally one of the absolute worst notes ever written in the whole history of humans. But it says, to help you, just in case you're lost. I lose my note. All right. Each F tests the simple effect of social blender condition within each level of the combination of the other effects shown. Okay. Just saying that is not a well-written sentence. Might be technically correct. So what are we doing now? What is the appropriate Bonferroni? So there's 1, 2, 3 of these. So we need 0.05 divided by 3. And so let's do that. 0.05 divided by 3. You get one of those infinite decimals. So I'm going to round this to 0.017. 0.017 is the new Bonferroni corrected alpha level we got to use to interpret everything. And where to go? 0.0017. There we go. Who knows? SPSS, gonna SPSS. So almost there, folks. So we gotta get proportion variability. So using the F formula, write the results for each simple effects test in APA format based on the SPSS output table univariate effect. So just leading you to that again. I don't want all your struggles to be trying to find stuff. I want it to be spent trying to interpret stuff. So, all right, social blending condition among participants with self-esteem. Well, social blending condition is not here, but there is low self-esteem. So this happens to be correct. So we got to fill in that F value. So I am just going to cheat and copy this. Another request from students over time so that they don't have to retype all the boilerplate nonsense each and every time. So let me get this set up so that it runs well. Oops. And then here as well. And one more. Kind of working. It's not great. All right, so that is what we need for our F-test. So let's start filling stuff in. So for low self-esteem, we've got an F with 1 and 18 degrees of freedom. So let's go ahead and pop those in. 1, 18. And I lost my parentheses somehow. Who knows? Oh, I gained whatever that thing was. So go off this whack mode. There we go. And less than or greater than, I guess we'll just kind of be stuck with it. So let me paste this down to the other two. And we'll start filling them in. So 118 is P less than. For low self-esteem, yeah, P is less than 0.05. So wait, no, this is alpha. This is alpha Bonferroni. So we can put 0.017 is probably the best thing to go ahead and throw in here. 0.017. And final thing we need is our eta squares. And this was the number one thing people actually asked me questions about. So how do you get it? What total do you use? Which I knew was coming. So you use the total, the same total that we had in the full model up above that you used for cooking or whatever it was. So all right, let's do it. So medium is, oh, sorry, we got a calculator, dirt. So what was that number? It was 191.976. That's what it was. All right, I thought it was 7. Having one of those days. So let's go ahead and get our sum of squares. You know, I'm going to grab it from the ANOVA table because we are almost done. Sum of squares is 72. So get my calculator up. We got 72 divided by 191.96. You get something really teeny tiny. So basically, that's too bad. Did I do that wrong? Let me try that again. 72, I think I did it wrong, divided by 191.96. And no scientific notation. There we go. 0.3757, that's going to round to 0.38. So 2 spots, or put that at the end of this 0.38. All right, let's do the next one. And I'll go a little bit faster this time. We've got degrees of freedom of 1 and 18 again. How convenient. I cheated and left it on there. I did greater than. Sorry about that. There we go. P is greater than 0.05, y'all. Okay, so next one is going to be significant. So get rid of some of this crud right here and put 0.05. Excuse me, take that back. I just did again 0.017. 0.7. Fine, verifying. Yep. I lost my eta squared, so let me get my eta squared back. All right, someday. I mean, this, at least, believe it or not, this was not as bad as last week's assignment. So what's here? We got 40 divided by that. So no, everything's significant. Oh no, that one's not. So 40 divided by 191.96. 40 divided by 191.96. We get 0.208, so 0.21 is what that one's going to round to. So let me put this in here. So far, so good. Where'd my Bonferroni head go up here? Love it. Less than our Bonferroni. Looks like someone named Scott did way too much erasing. 7. And of course you had to do it in teeny tiny mode. Of course. Absolutely, of course. All right. Soup. So close to being done up in here. And somehow I got that on my F. I'm not quite sure what I did. So let me just clean up so you guys aren't too confused. And all right. You ready? Yep, too many out here still. You are gone, sir. All right. Now it looks like we're mostly cooking with gas. We bold and get our little thing going. So F, font size 2. Man, I'm just screwing everything up in this sucker. Let's try this again. It says 12. This must be that thing where it does superscript or subscript. Let me unsubscript it. And yeah, that didn't quite work, did it? So unsubscript it. There we go. And apparently got an I in there for some reason. Someday I knew we'd totally get here. And I lost my F values too. Gosh, F value is 26.59. Then we've got an F value here that's equal to 14.95. And finally down here, an F of 1 in 18 is equal to, I can't do that one in my head, 3.74. That's what we'll do. So you are equal to 3.74. Is it significant? That one is not. And this one is. So I'm like, gosh, you don't want me but doing your stats write-ups today. All right. Significant, significant, not significant. Let's get that fixed. And finally, eta squared, so 10.125. 10.125 divided by 191.96 is 0.05. That's what I got. So hopefully it's right, since some of us named Scott make the darn answer key. All right, yeah, those are messy. Anyway, on the screen now is what they should look like. So let me just do the last thing on here, and hopefully you read that you're supposed to do an APA write-up. So scooting right along. So interpret the results of the two-way interaction between participant self-esteem and social blunder condition. What do they tell us about whether how independent variables interacted and affected were associated with the differences and dependent variable? Okay, so let me take you through the thought process on this. So there's a lot of writing. So the first thing I'm going to do is I know that the simple effects tests were done as a function of low, medium, and high self-esteem. So I'm going to start with just low people. And I'm going to say among low people, and I'm going to look at the pick too, this differed from this. So under which condition here did they rate the person higher? Whatever kind of reddish is. So it looks like that's no blunder. So low self-esteem people rated the person higher when they did not commit a blunder. Next one is medium. So medium is in the middle of this plot. So medium's here, and you get the opposite. Instead of blue being the lowest, blue is the highest. Blue is blundering. So maybe it made him endearing, who knows? But with low self-esteem, tend to crap on people. It's sort of my guess. Medium self-esteem, there's less need to do that. You can appreciate other people, that sort of thing. You like yourself. So then high self-esteem, we'll see what happens. So medium, again, it was statistically significant. So there is a difference. I'm going to go look at those two means or the picture. It's just as easy. Blunder, they rated higher than non-blunder, which is kind of odd. So medium rated the person as more likable when they committed blunder. So the flip effect. Finally, we got high self-esteem. Let's see what's going on with high self-esteem. So that is these two dots. These two dots are the closest together, by the way. And do note that up here, um, the follow-up test was almost there, but not quite significant. All right, it's 0.069. So bummer. So let's do high. So among the high, we didn't find any difference. That's not significant. So again, we're stuck with the blender didn't make it. They didn't seem to be impacted by the blender in terms of likability ratings, however you want to say that. So I'm going to say they rated it as equally likable. So, oh, I should have put low here. Low self-esteem. So let's do high self-esteem. Rated the person, rated people, I guess. The blender. So if you got high self-esteem, my read on this is you're just kind of like people, don't have to put people down in order to bring yourself up. So they tend to be pretty chill. And what happened to high? There we go. High rated. Don't see too many types out looking. High self-esteem rated, regardless. And I think we got a document. So that, my friends, is two-way ANOVA. In case you didn't know it, let me pop it up just for one quick thing. So APA template, the one you guys see. Let me see if I was mean or not. So far, no. It's just got fashion. Okay, good. Yeah, last year there was some weird stuff at that conference. They were talking about throwing people at volcanoes, and it was weird. So anyway, that's the assignment. Hope you did well, but correct your work so that you have the right answers and can use it as a reference when you get to the upcoming computational test. Have a good one.